Even the most powerful AIs out there like GPT-4 have this one fundamental flaw in how they think. They are absolutely brilliant at improvising, but they're terrible planners. So today, we're going to dive into a framework that actually teaches them how to think before they speak.
So what is an AI's biggest blind spot? It all comes down to how they create text, literally one word after another in a straight line that they can't ever go back on. Because of this left-to-right process, they can't really explore different ideas, they can't backtrack from a mistake, and they certainly can't look ahead to see if they're even on the right path.
To really get this, it helps to think about how we think. See, our brains kind of have two gears. There's System 1, that's our fast, automatic gut reaction. It's a lot like an LLM, just spitting out words. But real problem solving, that needs System 2, the slow, deliberate planning part of our brain. Right now, most AI agents are totally stuck in System 1, and that's a huge wall to climb for them to become truly autonomous.
And that's exactly why older methods, even really clever ones like chain-of-thought prompting, just hit a wall. They basically force the AI down a single path of reasoning. If it makes one wrong turn right at the beginning, the whole solution is pretty much doomed. There's no turning back. This visual just illustrates the core idea perfectly. Instead of being locked into that one single path, what if an AI could explore a whole tree of different possibilities at every single step? What if it could come up with multiple lines of thought and then, step back and figure out which branch looks like the best one to follow? And yeah, that is exactly the solution that this research proposes. It's a whole new framework designed to give AIs that deliberate System 2 planning power they've been missing all along. It's called the Tree of Thoughts. So what is Tree of Thoughts, or TOT? Well, to put it simply, it's a framework that lets a language model explore a bunch of different reasoning paths all at once. It can generate different thoughts, it can evaluate them, and then it can decide, do I keep going? Do I peek ahead? Or wait, let me backtrack and try something else. It completely changes problem solving from a straight line into a strategic search.
Okay, that sounds great in theory, but how does it actually work in practice? Well, it's this really elegant four-step process that basically transforms the AI from just a linear talker into a strategic planner.
The whole process unfolds in 4 stages. First, the AI breaks the big problem down into smaller, more manageable steps. Second, for each of those steps, it brainstorms multiple potential thoughts or solutions. Third, and this is the genius part, it uses the language model itself to grade how promising each of those thoughts are. And finally, it uses a search algorithm to look through this entire tree of possibilities to find the very best path to the final solution.
So, to prove this thing actually works, the researchers tested it on tasks that are just notoriously difficult for those linear thinking AIs. One of the best examples is a math puzzle called the Game of 24. The goal is to use 4 numbers and basic math to get the number 24. It sounds simple, but it can be really tricky. Using Tree of Thoughts, the success rate on this game was 74%. Just let that number sink in for a minute, because the comparison is pretty wild.
And here it is. This contrast shows you just how powerful this is. The previous state-of-the-art method, chain of thought, could only solve this puzzle about 4% of the time. 4! TOT's ability to explore and backtrack boosts that success rate all the way to 74%. That is not just an improvement, that's a revolutionary leap. What's really cool is that this idea isn't entirely new. It actually connects way back to the very foundations of AI research. Back in 1959, pioneers like Newell, Shaw, and Simon defined problem-solving as, a search through a tree of possibilities. Tree of Thoughts is basically the modern, supercharged, language model-powered version of that classic vision.
So what does this all mean for the future of AI? Well, for anyone out there building AI agents, this framework is basically the blueprint for creating systems that are truly autonomous, systems that can plan, strategize, and, crucially, recover from their own mistakes.
And the beauty of TOT for developers is just how practical it is. It's general, so you can apply it to tons of different problems. It's modular, so you can swap out different pieces. It's adaptable, and maybe most importantly, it's convenient. You don't need to do any expensive, custom training. You can give your AI agent a planning brain using the models that already exist. So, this all brings us to one final, pretty provocative thought. When an AI can actually explore possibilities, backtrack from dead ends, and essentially change its mind, what problems are really left that it can't solve?
This is for entertainment purposes only.